Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about multiplexer. Multiplexer is a combinational circuit that has many data inputs and a single output. Depending on control or select inputs. For n input lines, log n to the base 2 selection lines are required, or equivalently 2n input lines, n selection lines are needed. Multiplexers are also known as n to 1 selectors, parallel to serial converters, many to 1 circuits, and universal logic circuits. They are mainly used to increase the amount of data that can be sent over a network within a certain amount of time and bandwidth. There are different types of multiplexers. First one is 2 cross 1 multiplexer. A 2 cross 1 multiplexer will have two input lines, one output line, and a single selection line. 4 cross 1 multiplexer. It is a multiplexer that has four inputs and a single output. The output is selected as one of the four inputs, which is based on the selection inputs. So first we'll see about 2 cross 1 multiplexer. A 2 cross 1 is a fundamental circuit which is also known as 2 to 1 multiplexer that are used to choose one signal from two inputs and transmit it to the output. The 2 cross 1 max has two input lines, one output line, and a single selection line. It has various applications in digital systems such as microprocessors. It is used to select between two different data sources or between two different instructions. So here is the block diagram of 2 cross 1 multiplexer. So as shown here, you are having two input lines and one output line and one selection line. So this is the truth table of a multiplexer. So selection lines can be either 0 or 1, and since we have two input lines, it is represented as I0 and I1. I0 can be 0 or 1, and I1 also can be 0 or 1. So your outputs will be when both the selection lines and the input are 0, the output will be 0, no matter what I1 is. Next one is when selection line is 0 and I0 is 1, the output Y will be 1. So whatever you have in the input I0, the same will be present at the output if the selection line is 0. Next, if selection line is 1, whatever is present in the input I1, it is present at the output independent of the input I0. So the output of a 2 cross 1 multiplexer will depend on the selection line S0. When S is 0 or low, the I0 is selected, and when S0 is 1, I1 is selected. So based on this, we can write the expression as Y is equal to S0 bar into I0, which is since y is equal to 1 for S0 is equal to 0 and I0 is equal to 1, we are writing it as S0 bar and I0 plus the other output one is for S0 is equal to 1 and I1 is equal to 1. So you can write it as S0 into I1. So the expression Y is equal to S0 bar into I0 plus S0 into I1. So this is the circuit diagram of a 2 cross 1 multiplexer. So based on the expression given, Y is equal to S0 bar into I0 plus S0 into I1. So S0 bar, since this is S0, S0 bar is given by using a NOT gate. So output of this NOT gate is S naught bar. So the input to this AND gate is I naught and S naught bar. So the output of this is S naught bar into I naught. And here the second AND gate input is I1 and S naught. So the output is I1 into S naught. And we are adding these two using an OR gate and we will be getting the output Y. Next one is uh, 4 cross 1 multiplexer. So 4 cross 1 multiplexer, which is also known as a 4 to 1 multiplexer, it is a multiplexer that has 4 inputs and a single output. The output is selected as one of the 4 inputs, which is based on the selection inputs. The number of the selection lines will depend on the number of the input, which is determined by the equation log n. In 4 cross 1 mux, the selection lines can be determined log 4, which is equal to 2. So, 2 selection lines are needed. So the output of the multiplexer is determined by the binary values of the selection lines. When S1, S0 is equal to 0, 0, the input I0 is selected. When S1, S0 is equal to 0, 1, the input I1 will be selected. When S1, S0 is equal to 1, 0, the input I2 is selected. And when S1, S0 is equal to 1, 1, the input I3 is selected. So this is the truth table. So as I explained, when input 0, 0 means I naught, 0, 1 is I1, 1, 0 is I2 and 1, 1 is I3. So based on this, the expression is given as S naught bar S1 bar into I naught plus S naught bar S1 into I1 plus S naught S1 bar into I2 plus S naught S1 into I3. So this is the equation for 4 cross 1 multiplexer. So based on this expression, the logic diagram is drawn here. So AND gate represents the each and every product term and the OR gate will add all the 4 product terms together. Some of the applications of multiplexer are first one is data routing. The multiplexer is used for data routing in the digital system, which where they select one of the several data lines and reroute uh, in the output. Data selection, the mux is used for data selection. Uh, where they select data source according to the select lines. And analog to digital conversion, the mux are used in ADC to select different analog input functions. Address decoding, the mux are used in microprocessors or memory for address decoding. And the logic function implementation, muxes can be used to implement various logic functions. Several advantages and disadvantages of Mux are: first one, it is has a good efficiency in routing multiple input signals to a single output signal based on the control signals. Optimization, the Mux helps to conserve resources such as wires, pins, and integrated circuits. Next one is different implementation. The mux can be used to implement different digital logic functions such as and or etc. And next one is flexibility. Mux can be easily configured according to the requirements and accommodate different data sources, enhancing system versatility. Certain disadvantages are limited number of data sources. The number of input that can be taken by a multiplexer is restricted by the number of control lines, which can cause limitations in certain applications. And delay, multiplexers can have some delay in the signal path, which can have impact on the performance of the circuit. Complex control relational, the control logic for multiplexers can be complex, particularly for bigger multiplexers with a large number of inputs. And last one is power utilization. Multiplexers can consume more power compared with other simple logic gate, particularly when they have a large number of inputs. Let us take a few assessment questions. First one is, what is a multiplexer? The options are, it is a type of decoder which decodes several inputs and gives one output. And the next option is, a multiplexer is a device which converts many signals into one. Third option is, it takes one input and results into many output. Fourth option is, it's a type of encoder which decodes several inputs and gives one output. Yes, the answer is, a multiplexer is a device which converts many signals into one. Second question is, which combination circuit is renowned for selecting a single input from multiple inputs and directing the binary information to output line? The options are data selector, data distributor, both data selector and data distributor, and demultiplexer. Yes, the answer is data selector. Thank you for watching this video.